Hello everyone. Let us start with one another practice problem of section of solid. Here is the question. A pentagonal pyramid base 30 mm, side and axis 60 mm long, base 30 mm, axis 60 mm long, is lying on one of its triangular faces on HP, lying on one of its triangular faces on HP with axis parallel to VP, a vertical section plane bisect the top view of the axis and makes an angle of 30 degree with VP. Draw the sectional front view. Now let us first of all draw the projection of solids up to this point. Then after we will take the section and we will draw the sectional front view. So first of all we have to draw the plan and elevation in the first stage, as it is given that the pentagonal pyramid is resting on its triangular faces on HP. So in the first stage we have to derive the condition, or we have to take the bases on the right hand side, and we will draw the plan and elevation. So this will be the plan. We have taken the base on the one of the bases on the right hand side. Draw the plan showing the slant edge and the center. Project AB, CE and D elevation of the base. Project the apex point. Measure the axis height, which is 60 mm, and mark the O dash. Join O dash to A dash, B dash, C dash, C dash and D dash. These are the elevation of the slant edge. Now here we will see that this part contains two slant edges, O dash A dash, O dash B dash. That means this is a triangular face, and here it is given that the pentagonal pyramid is resting on or lying on its triangular faces on HP. So now we have to draw we have to take the triangular face on HP. So we have to take this edge on XY line, that is O dash A dash B dash on XY line. So measure O dash A dash B dash, give an arc, mark O dash A dash B dash. Then after measure A dash to D dash, give an arc and measure O dash to D dash, give an arc and mark D dash. Then after join these points O dash to A dash B dash, A dash to D dash, and then after this will be the base. Mark C dash E dash on the base, C dash E dash and the axis. So now we have shown the condition of the triangular face lying on HP, and if the triangular face is on HP, we can see that now the points of the base are rotated. So in the top view of the in the top view the base is going to be visible. So first of all draw the base. You can see that AB is on the right hand side in first stage, and in the second stage AB is rotated, so base is going to be visible. So first of all draw the base. Then after slant edge OC, OD, OE, OA and OB by using the rule of intersection of the visible edge and hidden edge. So OC is going to be visible, OB hidden, OD visible, OA hidden, OE visible. Now we have to take the section of the pyramid, and here it is given then a vertical section plane. If a plane is a vertical plane, then it is perpendicular to the horizontal plane. That means here it is given that a plane is perpendicular to HP and inclined at an angle of 30 degree to VP. Perpendicular to HP, inclined to VP. That means the cutting plane is AVP. So cutting plane is AVP, and it bisects the top view of the axis. So if the cutting plane is AVP, we have to take the cutting plane in the plan, or we have to show the cutting plane in the plan, and the angle of the cutting plane is 30 degree and it bisects the top view of the axis. So first of all show the top view of the axis. It is O1 and 1. So this is O1 and 1. Now find the midpoint of O1 and N1. O1 and N1 is the top view of the axis. Find the midpoint. So open your rounder more than half of the line O1 and N1 and give an arc upwards, downwards. It is a perpendicular bisector method because we have to bisect the top view of the axis. So take a measure more than half distance on the rounder, more than half of O1 and N1. Give an arc on both sides, 1 2 and 3 4, and mark the midpoint of the axis. So here will be the midpoint of the axis, and after defining the midpoint of the axis, show the cutting plane incline at an angle of 30 degree to the XY line, because the cutting plane is inclined at an angle of 30. So show 30 degree and draw the cutting plane. Show the cutting plane. So here is the cutting plane. It is inclined at an angle of 30 degree to the XY line. So here it is a cutting plane. Now we have to show the points of the intersection of the cutting plane to the pyramid. So let us show the point of intersection of the cutting plane to the pyramid, starting from the visible part. So starting from this point, this is 1, this will 2. Here is hidden outline. We will give the name on the hidden outline when we comes backward. So 1 2 3, it is hidden line. 4, now on the hidden line 5, on the hidden line 6. So mark the point 1 2 3 4 like this, visible outlines, and in return we have to give the points on the hidden outlines. So mark the points of intersection of the cutting plane with the pyramid, and as we are going to remove this part of the pyramid to show to observe the section of the pyramid, so this part is going to be light, and the part nearer to the observer, we have to remove the part of the pyramid nearer to the observer. So we will remove this part to observe the section in the elevation. So this part is going to be visible, and this is light lines. This part is shown by the light lines. Now to show the cutting plane, let us project 1 2 3 4 5 6 in the elevation. So 1 is on the bases BC. To project up to bases BC, so this is first point, 1 dash, then after 2 3, likewise 2 3 2 2 3 on the slantage, 3 is on the slantage OD. So project 3 on the slantage OD, then after 4 on the slantage OE, project it up to OE. 5 is on the slantage OA, so project the 5 on slantage OA, and 6 is on the slantage OB. So this is on the slantage OB. Mark these points of the section. This is 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Join these points to show the section. as we are going to remove this part, so the part of the apex is going to be removed. So show this part as a light part, and this will be the section or section in the front view. Or sectional front view of the solid after taking or after cutting the pyramid by AVP, inclined at an angle of 30. So this is the sectional front view. Now let us do one another example. A cone having diameter of base 60 mm and axis 60 mm long is kept on HP on its base. Now the cone is kept on HP on its base, horizontal plane. And the diameter of the base is 60 mm and axis height is also 60 mm. Is kept on its base on HP. So it is kept on its base on HP. So let us do this work. First of all, projection of solids, then after we will take the section. So it is cut by a plane such that the true shape of the section is an isosceles triangle of base 40 mm. Draw front view and sectional top view. So now first of all, draw the base of the cone. It is a circle having radius equal to 30 mm, diameter 60 mm. Divide the circle into 8 equal parts, as we have shown the division of the circle already. So divide the circle into 8 equal parts, A, B, C, D, E, F, G, H. Join the generators, or show the generators by joining the points of the base. So join the points of the base to the apex point or plan of the apex point. Project the points on XY line. So this will be the base A, B, C, D, E, F, G, H. Base. Measure the axis height, which is 60 mm. Mark the elevation of the apex point O dash. Join the elevation of the apex point to the points of the base OE, ODOF, OCOG, OBOH and OA. Now after drawing the projection of solid, let us discuss about the section. It is cut by a plane such that the true shape of the section is isosceles triangle of base 40 mm. Now here the cutting position of the cutting plane is not given, but here it is given that the true shape of the section is an isosceles triangle of base 40 mm. So first of all, we have to derive the base in the top view of the section. In the top view of the section, so first of all we will divide the base of the isosceles triangle over here in the top view of the section, and for that we will measure 40 mm base length, 20, 20, mark the points and extend these points on the periphery of the base over here, 1 and 2. So this will be the base of the section and it will be the base of the isosceles triangle. It is equal to 40 mm. So the cutting plane will pass from here, from this point, and in part of conics in chapter number 2, chapter engineering course, in the discussion of conics we have discussed that when the cutting plane cuts the base and pass from the apex point, when the cutting plane cuts the base and pass from the apex point, then the curve of intersection is a isosceles triangle. So right now our cutting plane will pass from here and it will also pass from the apex point. Here it cuts the base and it will pass from the apex point. Show the cutting plane like this, because if you want to define the curve of intersection as a triangle, the cutting plane should pass from the apex point and should cut the base, and the point of the base, this point, we have defined it from the plan. And in the plan, first of all, we have derived the baseline of the triangle. It is 40 mm. So first of all, derive the baseline. So we want to draw the section in the top view. This point will be over here, so it will be a triangle in the top view. So the sectional front view will be the triangle having base length 40 mm. So this will be the sectional front view having base length 40 mm, and we have to remove this part, so this part will remain as it is. So this part will be considered as the dark part and this part should be light. As we are going to remove this part, the section will generate in the top view, and the section will be the section will be a isosceles triangle having base length 40 mm. Now we have to draw the true shape of the section in which the base of the isosceles triangle should remain 40 mm. So it will remain 40 mm. So now first of all, mark the points of the section. This is 1 dash, 2 dash and 3 dash on the base. So 1 on the base over here, 1, 2 at the center and 3 over here. Now to draw the true shape of the section, first of all we have to take the projection from the, we have to draw a line parallel to the cutting plane, which is our x2 y2 line. Now take perpendicular projection from 1 3 2. So this will be the projection of 1 3 and this will be the projection of 2. Now measure the section, that is 1, following the projection from xy line. So measure the top view of the section, that is 1 from xy line, and give an arc over here. So this will be 1, 3 from xy line by following the projection. This will be 3 and 2 from also from the xy line. This will be 2, and as we know that this length is 40 mm, so in the true shape also the base of the triangle will remain 40 mm. So now join this part. So true shape is an isosceles triangle. Isosceles triangle having base length, base is 1, 3 and 2. So the base is 1, 3 and base is 40 mm. True shape of the section is an isosceles triangle of base length 40 mm. So we have measured this part as 40 mm and also this part will remain 40 mm in the true shape. So now you can see that the true shape of the section is an isosceles triangle having base length 40 mm. So this will be the true shape of the section and sectional top view of the cone. And always whenever we will take the section of the cone, we have to know that or we have to know the curve of intersection of the cone, that is conics. We have to define the different section of the cone or conics. That is, sometimes we can also find the parabola having base length 40 mm, So if we have to derive the parabola having baseline 40 mm, we have to derive the base like this also. And we also know that if you want to derive the parabola, first point of cutting plane will be over here, and then after we will know that we already know that the cutting plane, if we want to derive the curve of intersection of the parabola, the cutting plane should be parallel to one of the generator. So in case of if you want to derive the parabola, we have to take the cutting plane parallel to one of the generator from this point. Base will remain same. So you can also draw the parabola having baseline 40 mm. Thank you.